Hey, glad you could be with us. Welcome to another stellar edition of .NET Rocks, the internet audio talk show for .NET developers. I'm your host in New London, Connecticut, Carl Franklin, and my partner, Mark Dunn, my co-host. How are you down there in Montgomery, sir?
Hey, Carl, I am doing fine.
How's the heat down there?
Oh, it's not too bad. It's been a really nice day.
Oh, that's good.
Yeah, the last couple of days it's rained very hard.
That was a great show we did last week, wasn't it?
Yeah, that was a lot of fun. I'm glad we got around to that.
Those training stories are just something else.
There are a few more.
Good. I can't wait. You have any you can share with us right now?
No, not at the moment.
Okay.
I have to protect the innocent, you know.
That's true.
Or the guilty, as it may be.
Just great. I had so much fun doing that show. It was kind of nice just the two of us to talk. Well, anyway, so what's happening in .NET world? I haven't seen anything really in the news that's outstanding.
No, I have. I actually looked today. I've been teaching down here this week, and I was kind of scouring the internet for anything new and couldn't find anything that was significant.
Either it's hiding, or there's nothing there, or our searching skills are lacking. One or the other.
It could be a combination of all of the above.
Probably all of the above. Yeah, I was just gonna say. Well, our guest tonight is Juval Lowy from iDesign, and he's been on the show before, of course. He's the founder of iDesign and its chief architect. He's also a seasoned software architect and developer specializing in system architecture and large applications design. So he helps iDesign customers design scalable, robust, reusable, and extensible enterprise applications, verifying that the customer has the design it takes to achieve the required quality, scalability, security, availability, and throughput goals. We could go on and on about Juval's qualifications, but he's a fantastic guy, a great developer, very smart, and has been responsible for educating a large portion of the .NET community on some of the more system functions, I guess you would call them, the lower level things that are going on in the framework. Welcome, Juval.
Hi, guys.
Hey, Juval, great to have you with us.
Glad to be here.
You're down south yourself tonight, aren't you?
Yeah, I'm actually based in San Jose, California, but this week I'm consulting in Atlanta, where you're usually based.
He's stealing your business, Mark.
Yeah, that's right.
You're down there in Montgomery, you know, and Juval comes in and takes all your business away.
Gotta have somebody watching the back door up there.
So we had this scheduled because some very important things have been happening in the news recently. And Juval got the green light to talk about them, namely the next version of C#, which are all very interested to hear in what you can tell us about it without getting in trouble, we hope.
Right.
This is a scoop, as far as I know, is it not?
And in fact, we're also going to discuss it at VS Connection in October.
That's right.
That's right.
All right, so you get a preview tonight, eh?
Yeah, we managed to squeeze it in into the conference schedule at the last moment. Carl pulled it through.
Yeah, can't wait for that.
So the features we're going to talk about tonight, those are in the Would-Be release?
Those are what is known as Would-Be, the codename for .NET 2.0. And there's many new features of the application frameworks themselves, but there's also language-specific features of C# and also enhancement to the environment. But we're going to talk tonight just about the syntactical linguistic enhancement of C#, and these are, of course, generics, iterators, partial class, and anonymous methods.
Cool. And I also might want to mention that VBNet is also getting a facelift, but we're just going to focus on C# tonight.
That's right.
So tell us about generics. I've heard a lot about them. Of course, have no idea what they are, as most people don't.
Isn't that old people?
Yeah.
Or that's geriatrics, I'm sorry.
So actually, I mean, it is in a way related to geriatrics because generics are the managed code equivalent of C++ templates.
Okay.
And templates were one of the most powerful feature or aspect of C++. And templates, of course, were not introduced to C++ in day one. They were a later addition to C++. So let's first define maybe the problem you're trying to solve with generics. Then we can discuss what they are. And so imagine you're trying to come up with some sort of a data structure, like a stack or a queue or a binary tree or any kind of custom collection. And that collection has, or that data structure has specific algorithm that deal with how do you sort it, how you add information to it, how you remove information from it, how do you iterate over it and such. And what you would like to do is you would like to use this data structure with the various data types, with integers, with strings, with customer objects, with order objects, and so on. The problem is, with .NET as it stands today, you have two options. One is to just use generic objects, where you just say, I'm going to use object. And your code will work just fine, except anytime you want to do something interesting with the item inside the data structure, you're going to have to cast to an object and cast from an object. Now, if you're dealing with reference types, classes and such, then that implies only a small overhead. But if you're dealing with value types like integers and such, there's a significant performance penalty for all this object allocation and deallocation, and it increases the pressure on the managed heap, and there's more garbage collection. And the code itself is not type safe, because every time you do a cast, you're basically playing Russian roulette with your compiler, right? It may have an exception.
Right.
Yeah.
And so the other option that you can have is just duplicate the code, one for integers, one for strings, one for customers, and such. And that's
not
resulting in code bloating, and it's not a very practical approach.
That's
right?
no good.
And in addition, there's no way for you to specify or rely on the compiler for doing type safety with the objects themselves. For example, if you want to compare two things, if you're just comparing generic objects, the compiler may or may not let you do it. But if you're comparing actual objects, how would the compiler be able to tell whether they support a particular interface or comparable, or the comparable operator and such? And so there's all sorts of issues involving that. And so the solution C++ came up with was templates, where you define the structure with a generic type, like use the letter T. You're not committing to any particular type. And you write all the algorithm with a generic type T. And when you're going to use it, you're saying, okay, I'm going to use the data structure with an integer or a string or an object. And that, of course, is a phenomenal idea, being able to do that. And in essence, C# generics are similar to C++ templates. However, the implementation of the mechanism is very different.
Well, before you get into that, let me just make this clear, in my mind anyway. So you're saying you're creating a new data type sort of label, right? A data type template, I guess, is a good word for it.
Right.
That basically isn't in and of itself a data type. Is more like an alias to another data type?
No, you are defining a data type like a queue or a stack, but what you're storing or collecting is a generic type. The type itself is you just mark it as a label, as a T, or whatever you want to call it.
Okay.
Right. I think I'm hearing you say too that we don't pay the unboxing penalties of having to deal with value types.
Right. And so that actually got to do with the way C# went about to implement that. And traditionally, C++ templates were nothing more than elaborate compiler macros, meaning when you instantiated the data structure with a particular type, the compiler simply duplicated the code that was generic till now with the template and just replaced every occurrence of T with the word int, and then compiled your code that way. The problem with doing it this way is that you got no compile time checks. In fact, the compiler never even compiled your code until you actually went about to use the generic structure. So if you're doing a class library with generic data storage, well, guess what? It's never going to get compiled. And it resulted also with significant code bloating, because every time somebody defined a stack with an integer and somebody else defined another stack with an integer, you just bloated the memory with lots and lots of code.
Okay.
And there was basically no way for you to actually specify constraints on the types. And the compiler basically took your word for it that the underlying type supports an assignment operator or implements a particular method. And if it didn't, then when somebody went ahead and instantiated the type with a particular type inside, that thing didn't work. And so the C# architects came up with a drastically different scenario. Their scenario was, instead of treating generics as just macros, they actually have equivalent representation of generics in the IL. And so what the C# compiler actually generates is legal IL in .NET 2.0, of course. And at runtime, it is up to the JIT compiler to compile that generic IL into something that has a specific type into it. And because at runtime the JIT compiler already knows whether it already implemented a stack with an integer or a stack with a float, it's able to actually reuse that implementation. And that's a very important benefit. So there's no code bloating.
Right. Very cool. So you mentioned constraints. How are they implementing constraints? Are you doing that through interfaces when you define a generic?
So the problem concern I'm trying to address is, again, an inherent problem with this mechanism. If you're defining a data structure like a queue or a stack, and you want to return a new object of type T, who said that T supports a default constructor? Who said T is doing that? And so you have to instruct the compiler and saying, yes, this type supports it, and this is what constraints are. You are saying the type supports this constructor, or the type derived from this particular base class, or the type implements this particular interface.
So it goes beyond simply defining a constraint as an interface then?
Correct. There's interface constraints indicating what interface the type supports, and there's base class constraints, and there's default constructor constraints.
Still trying to figure this out in the big picture, and pardon me, and I think maybe some other people listening are also struggling with this. Let me just put it in terms of a framework of something that I understand. How is this different from, say, a variant or another kind of late binding mechanism? You mentioned what the problem was with the object, just defining things as objects. Internally, you have a lot of boxing going on for value types. But does this essentially solve a late binding problem in a much more efficient way? Is that basically what we're doing here?
Yes, because you get the early binding performance and you get the early binding type safety as well. With a variant, it's basically like an object. Anything goes, right?
Right.
And so you can put a string in, try and get an integer out, and you explode.
Yeah, exactly. Surprises it.
Surprise, sort of a deal, right?
Right.
And with generics, the compiler is on your side. The compiler is going to refuse you to try and get an integer from a stack that stores strings.
Okay, so it has rules, but it's still late bound.
No, it's all done early bind, because when the client side uses a data structure and commits to a particular type, the compiler looks at the metadata of the generic data structure and knows how to infer all those types out of it. And so you get all the type safety of early binding, and you also get the performance of early binding, because there's no boxing, unboxing, less pressure on the heap and such.
But you get the functionality of late binding. I'm trying to understand.
No, it's not functionality, it's the versatility.
The versatility.
Of being able
the
to
flexibility.
Preserve your algorithm, because you develop the algorithm
Right.
how to manage data structure in a generic manner.
Yes.
And then different clients can reuse it with different types without actually incurring any performance penalty, any type safety
That's
issues.
what I'm getting at. You're using it so that you're using it in the place where you would maybe use casting with reference types, but taking that to make it work with classes that aren't necessarily related through inheritance. Is that?
Inheritance is a whole different story with generics. I don't know if you want to get into that. It raises all sorts of interesting issues.
Well, that's what we get with casting with reference types, right? Because when you cast, you have to cast to related data types.
Yeah, you can only cast in .NET to something on the same class hierarchy.
Yes. Right. So with generics, what I'm getting at is you can develop algorithms that may use completely different data structures that aren't related at all. Inheritance has nothing to do with it.
That's right. Inheritance has nothing to do with generics.
Right.
And so, think of an example that you went to the trouble of developing a binary tree. Now, writing a real-life binary tree is a non-trivial amount of programming. It requires about 2,000 lines of code. Now, why is it so complex? The actual insertion and removal of items may not be that complex if you're not doing a balance tree. But if you're doing a balance tree, there's lots of thought that goes into how to do it and keep the tree balanced and such. And you want to reuse that algorithm regardless of the actual type you store in the tree, be it an integer or a string. And that's really the power of generics, being able to reuse this investment.
Get it. Light bulb on.
Yeah.
Yeah.
And on top of that, you also get a significant performance benefit. Because if you're using it with integers, you're only paying for integers.
That's
in
great.
fact, I suggest the listener to actually do an interesting experiment. Implement a trivial stack that does push and pop. Do it once with integers. Do it once with objects, but store inside integers and do boxing and unboxing. Put it in a tight loop. Do it 10 million times and measure how time it takes. And you're going to see that the one that's using the integers is a fraction of the time that uses the objects.
Well, sure. Yeah.
And so that's a huge benefit for generics. Now, because generics are actually part of the IL, there's actually no reason why any language in .NET can't consume it.
Mm-hmm.
You can consume generics from inside J#. I mean, there's no reason why you can't do it.
Neat.
That's great. What a great feature.
Yep.
Yeah.
And this is something that the C# community has been eagerly waiting to. I mean, granted, C++ didn't get templates in day one either, okay?
Yeah,
it took a few years.
Right.
But once you give somebody something, you can't just take it back, right? So those with C++ background are missing generics because it becomes part of your toolset, part of the things you use to apply to solve problems.
Sure. And doing it the other way isn't going to...
And doing it the other way is just
waste of time.
Impractical and waste of time and performance. Yeah.
Right. Hey, Carl Franklin here. Glad you could join us. I was just up at the MSDN magazine website, and I noticed that the preview article for next month is written by our friends Ken Getz and Brian Randall. And you know Ken. He was a guest on the show and is very popular speaker and app dev trainer. And the article is called Bring the Power of Visual Studio Net to Business Solutions Built with Microsoft Office. And what they actually did is use the public beta of the Visual Studio tools for Office and have some sample code that creates a little Excel application using Visual Basic.NET or C# code that retrieves data and charts it. And so this is all document-centric programming here in Office 2003. Along the way, they talk about code access security and some other great stuff. So a good article to go check it out. It's at msdn.microsoft.com/msdnmag. Now let's get back to our talk with Juval Lowy here on .NET Rocks. Hey, don't you go away. So what else is new in C# 2.0?
So the other cool feature is called iterators. And iterators solve a different problem altogether. Imagine you're trying to implement some sort of a collection again, and you want to use the for each statement on it. Now, according to the .NET specifications, to implement an iterator, you need to implement an interface called Inumerable.
Yeah, that's right.
And Inumerable has a single method called getEnumerator, which returns an object that implements the interface Inumerable. What's good about the for each statement is that you can iterate over a structure, or actually several customers or clients can iterate over the same data structure, because this is called the iterator design pattern, because you're actually factoring out into a separate object the state of the iteration. And so one guy could be iterating it in the middle of the iteration, somebody else starts a new iteration, and you can have different iterators at different states iterating over the structure. And so that's much better than actually just trying to iterate manually over the collection yourself in some other way, which has significant deficiencies. One would be that you expose the internal data structure to the consumer of the class, and that's always bad.
That's interesting, because some tests that we've done indicate that a for next loop in Visual Basic.NET anyway I don't know about C#, but a for next loop is going to outperform a for each loop.
Well, in C#, the for each statement is actually converted to a while loop. And it uses the iterated design patterns to shield the person doing the iteration from the actual data structure, because ideally what you would like is you'd like to have exactly the same iteration code, regardless whether you're iterating over a linked list or an array or a binary tree or any kind of structure.
Sure.
And if you expose the nitty-gritty of the actual data structure to the outside world, then the code is no longer generic. You have to modify the code every time you change the data structure. In addition, it makes concurrent iteration or traversal of the structure much more complicated. And so factoring it into a separate iterator is a proven design pattern that's been used whenever you want to actually shield the consumer of a structure from the actual structure layout.
Okay.
That's a done deal, okay? That you can do today in .NET 1.0. You don't need .NET 2.0.
Mark, you were going to say something there?
I was going to say, if you're using a for each loop, you're maintaining the state yourself because you're taking care of the iterator. If you're using a for each loop, then you're counting on the Inumerable interface and whatever implementation the author of that object has put into it,
right,
to maintain the state machine.
Right. Because who maintains the state machine and how you do it can be very trivial if you have just an array as an internal data structure, in which case your state is just some sort of a counter or an indexer. But if your data structure is much more complex, like a binary tree, and the iteration over it is done recursively, how do you maintain the state for that? Right?
Yeah, good point.
Good point. And so it's a borderline impractical programming task. And so implementing a for each, being able to use your structure in a for each statement is nice in a conference demo where you just use over an array of string or something trivial, right?
Right.
But in real life applications, that's not the case. You do have complex data structure and which have either interleaved data structure or some recursive data structures. And so putting that inside the iterator pattern becomes next to impossible in practical terms. And so the C# iterator feature relies on the compiler to generate a state machine for you. Because if you think about it, there's only so many ways you can actually iterate over something. You can use a for loop, you can use a while loop, you can use a do loop, you can use recursion, you can just put all the calls to the structure in line instead of doing it in loop. There's just so many ways of doing it, right? And if that is the case, the compiler could actually diagnose which way you're using it and generate a state machine for you. And the first time you look at it at work, you're saying, oh, wow, it can't be that smart. And it is.
So that's cool. So you no longer have to worry about implementing the interface and writing the code to handle the iteration yourself.
Correct.
And that's all put in by the compiler.
That's all put in by the compiler.
Wow.
In fact, in many data structures, even if the iteration itself is relatively simple, like you have a linked list of some sort, right? It's not a big deal to write the state machine for that, but typically you want to iterate over it in many ways. You want to do it, front to back, back to front, reverse, random, something, right? And if every time you're going to change the iteration pattern, you're going to have to duplicate some state machine and bloat the code, you're going nowhere. And using the iterator pattern, using the iterator feature, it's done with a few lines of code.
Hey, that's great.
Right, and that's in the would-be release, is that right?
That's all in the would-be release, correct.
All right, cool, very cool.
Probably we should mention at this point that these features were actually first unveiled by Microsoft in Uppsala in November last year.
Yeah, that was by Anders Hausberg, right?
Correct. The chief architect of C#.
Yep.
Well, that's very exciting. I'm hoping some of these features make their way to VB.NET as well.
Yeah, definitely. We'll have to work on that. So what else is in the can, Juval?
So there's another feature called partial types, which deal with a problem or deal with a situation where you may want to have one guy defining a class in one file and somebody else in a different file adds features to it or things like member variables and implementing methods and such. And in .NET today, everything has to be in the same file. You cannot span a class definition on multiple files. And the real-life issues involved with that is, for example, source control. If I'm checking out the file, you cannot check it yourself and do some work on this class. And that's not too good.
Unless you use inheritance, and now you're
no, but
unnecessarily...
I don't want to change my object modeling just because of my source control
Yes,
needs.
that's exactly my point. You don't want to do that.
You
just
don't want
for
to do
purpose.
that. And so people have resorted to all sorts of kludges, such as multiple checkouts and all sorts of, shall we say, non-hygienic behavior. And partial type lets you, kind of like in C++, where you had a header definition and a C++ definition, you can actually have, it's not a header definition because there's no distinction between a header and a CPP file. It's all the same file. What you basically do is you can split the class definition across multiple files, and as a compiler churning over your code, it simply collects those things and compiles it into a single cohesive class. Once the IL is generated, it looks just one big class. The fact it's coming from different source files has no recollection.
So similar to an include idea.
More powerful than include in many respects.
Sure, but the idea is the same. You want to be able to split it out over multiple files.
This is nothing like a MultiFile Assembly, is it, Juval?
Correct. Got nothing to do with MultiFile Assembly. This is only dealing with in which source files the class resides. And by the way, it has to all go into the same assembly. A partial class cannot really span multiple assemblies.
And as we found out, that really doesn't happen all that often, a multi-file assembly.
Yeah, that's actually another true statement. It's something that, if it's going to happen, it's probably going to happen in future versions of this assembly. In version 1.0, rarely do you have to actually have multi-file assemblies. Yeah. I've actually found some other thing to be true in that statement. I've also found that the team boundary is the assembly boundary, meaning it's very rare that you're going to have different teams working on the same assembly.
Yeah.
And if you think about why this feature was available in the first place, it was to support multi-teams working on different binaries combined into a single assembly. But in reality, this is not the case.
Sure. Well, that's a great feature.
Partial type, yeah.
Yeah.
Yeah, just there's some gotcha, I think, that if you're used to maybe modifying or maintaining a file, and you want to look at the source code and look for effects or what's going to happen if you do a change, now just looking at a single file doesn't mean anything. You literally have to scan all the files in the project looking for potential parts of your class.
Yeah, we're in partial type hell now.
Because every one of them could actually contain a shred of class somewhere, right?
Right.
So I think on top of that, you need to have some sort of development standards.
Discipline.
That maybe uses file name as a convention of indicating what's inside, or type _ partial.cs sort of a deal, right, where you know these are all the parts.
Yeah.
Or extensive use of the class view that would aggregate for you the different pieces, right? Because the class view would actually show you all the things it has.
You know what I'm really looking for is a nice way to deal with configuration files without having to actually go in and edit and worry about case sensitivity and all that.
Yeah.
Join the club.
I hate them.
Right. But
I wish you could snap your fingers and have UI for all of those things, you know?
Oh, this is configuration editor, yeah.
Yeah. There are some out there I've seen, but I haven't. It's been a while since I went looking, to tell you the truth.
Right.
So what's the fourth and final feature you wanted to lay on us?
So the last feature is called anonymous methods, which is somewhat, in a way, it's the most esoteric of these features, and I personally don't think it's going to be that much useful, although it's definitely a very powerful feature. Imagine a case where you have to pass a delegate to some methods to invoke a method on your behalf, and you're not going to deal with multiple targets in this delegate. You're not going to use it for events. You're not going to use it for any of the other things besides just passing it somewhere. And so you typically have to go through the trouble of defining a delegate and defining the method and binding them together and passing them onward. And the anonymous method feature allows you to skip the phase of defining basically a method with a name. You simply square the code sort of in place, and the compiler will do the right thing and wrap it with a delegate and pass it in.
Huh.
So I don't have to do something like an add handler to tell it the function name? Is that what you're saying?
Well, if VB.NET is going to support it, I have no idea what the syntax is actually going to look like. But VB.NET, I don't know if it's going to support it ever, this sort of thing, but it's probably unlikely to look like the add handler syntax. Because what you're going to do with an anonymous method, you literally squirt the code in sudo. And the compiler is smart enough to pick up the pieces and make it.
You what the code? What did you say? Squirt?
Squirt it. You just put it inline where you want to pass it a delegate. And you simply put the code inline.
Wait a minute. Did you say SQUIRT?
Squirt.
Squirt.
Yeah.
You squirt the code.
That's a technical term, Carl.
It's a technical term, yes.
I never heard that before.
Oh, code squirting, yes.
Code squirting.
You never did any code squirting when you were a kid?
You must be the squirt king of C#. We're gonna make a T-shirt for you. So squirt the code just means to just fire it in there.
You just put it in place. You don't have to even define a method.
Okay.
And the compiler would pick up the pieces, wrap it in a nice delegate, and pass it in.
Well, I want to go squirt some code now.
Yeah. Okay, yeah, I can see that. That's neat, but I don't know if I want to do that all the time.
Right, and like I said, in my opinion, it's somewhat of an esoteric feature. I have to really get out of my way to find an example where
that's what I'm trying to think of.
Where I would want to use that.
Somebody must have had a good reason to put it in there. Maybe we can dig that out a little bit.
Well, it's again, in the cases where you are, I mean, I have actually an example where I would like to use it. For example, you know that in Windows forms, you can only call controls on the thread that owns them.
Right.
Yeah. And so Windows forms provide implementation of interface code isynchronize invoke, which has a method called invoke that you're supposed to call it, passing in a delegate targeting a method on the control.
Right.
And the implementation of invoke would marshal the call to the correct thread and have that thread execute the call.
Right.
This actually works just fine, okay? Unfortunately, well, what do I want to use?
Squirt?
Unfortunately, that pollutes the client's code because now the client has to do all the yucky plumbing of getting asynchronous invoke and calling invoke and doing the error handling and preparing a delegate, preparing an object array and passing it in and dealing with all this stuff.
It's a bit of work.
It's a bit of work. Now, if you only do it once in a while somewhere in your code, no big deal. But what if you're always going to set properties on different threads and such? And so the solution I found to be the most useful is to derive from the controls you're working with. For example, if you have a label control, simply derive another label from it called safe label. Override the text property, and inside the text property do the invoking with the invoke method. And so whoever is using it now doesn't care about, it's always going to execute on the right thread.
I was just doing that in my sockets class on Monday, as a matter of fact, using that same exact technique. Yeah, right. Making safe versions that you don't have to worry about calling the delegate, because you're going to call it from multiple places. You don't want to have to create a delegate every time.
Right, and so the thing is, if you're only doing it with a text property, no big deal, you just do it. But suppose you're saying, okay, I'm going to replace the entire Windows Form class library with my own version of safe controls because I'm sick and tired of having the environment not be smart enough to do it for me.
Right.
Nudge, nudge, by the way.
Yeah, right. Yeah. I agree.
Right?
Yeah, absolutely.
So what? In that case, you're just going to end up defining bazillion delegates with bazillion methods handling them just for the purpose of using a delegate.
Right.
So using anonymous method, that task would be much easier because you would just turn around and just squirt the code in line every time you want to use it and just be done with it.
Okay.
So in cases where you need to pass delegates to other methods to call things on your behalf, just for the sake of not creating a delegate, you can use anonymous methods.
Okay, I can see where that would work.
Right.
Yeah.
So perhaps if you're doing a large framework, it's useful, right?
Sure.
And those things, it's somewhat off the beaten track in some cases, right?
Right.
And so, by the way, on the .NET Rock website, we're going to put a link to Anders' Hasberg presentation from November.
Okay.
And in there's an example for using anonymous methods in the context of a Windows Phone application that has a button and such. So
that's great.
Maybe the listeners can take a look.
Mark, you have any questions? I got a few, but
no, I mean I'm still trying to kind of get my head wrapped around the anonymous method.
I think it's
I would like to
code.
kind of talk to Juval at some point during the show about the topic has come up before. Why is the perception that C# programmers are worth more in the marketplace than VB.NET programmers?
It's because guys like Juval are bad-mouthing VB all the time. That's the problem.
Oh, is that the reason?
Is that the reason? Oh, come on. I'm actually the only guy I know of that goes both to the VB.NET design reviews and the C# design reviews.
Yeah.
I don't know if you can say that, by the way. You may have to scratch that.
We're doing, by the way, at Dev Connections in Palm Springs, where this is a first as far as I know. We're doing sessions for both programming audiences at the same time. So people will be, who normally do VB-only presentations, are going to have to supply their code in C# as well, and vice versa. So you'll be able to get, no matter which language you use, you'll be able to get anything out of all of the sessions.
Right. But by the way, I mean, going back to Mark's question, the fact that the languages are the same doesn't mean the developers are the same.
Yeah, amen, brother.
And, I pondered a lot this question myself as to, if those languages are the same, why should I choose this versus the other? And it suddenly dawned on me what the fundamental difference is. And the fundamental difference is that there's really two types of life cycles in the way people develop applications. If your number one goal is being first to market, and you optimize everything for being first to market, you're going to make decisions that are going to affect your product lifecycle and the cost of long-term maintenance significantly. And that's the first statement, right? And if your number one priority is minimizing the cost of long-term maintenance, then proper object-oriented modeling and using generics and those things are your number one priority, not necessarily how long it took you to generate the code for the first time. And so,
good point.
For the long run, the two languages, in my opinion, are going to diverge to better serve their target audience. For example, we've seen at conferences that the VB.NET number one feature for would-be is edit and continue.
That's right.
Right?
Yeah, it's all about, I want my program to run as quickly as possible.
Right. But you know what a typical C# debugging session looks like? I'll do an imitation now, but it's over radio, so it may not actually pass through. You lean back in your chair and you look at the screen, and you scratch your chin, and you lean the other side, and you lean again, and you turn around and you come back, and you go to the water cooler and you come back, and you continue to stare at the screen. Then you press the step next line. Right? So if that's your debugging session, who cares about edit and continue? It's not high enough on the priority list for you, right? Sure, it would be nice if you can give it to me, but if you give me generic, I'm going to be happier, right?
Yeah, right.
And this is why we have this divergence, just to serve the target audience better. And so I don't think it's not that VB.NET is better than C# or the other way around, depending on the task at hand that you want to do. Now, if you want to talk about salaries, turns out that those that design for long-term maintenance traditionally charge more for the services than those that drop buttons on a form and ship it earlier, right? It's just the nature of the world. And so if the server you're referring to, we've all seen the results, was labeled instead of C# coder salaries versus VB.NET coder salaries would be system developers versus application rapid developers, you wouldn't say anything about the gap in salaries, right? It would make perfect sense to you, right?
Well, what you're saying, I think, jibes perfectly with my opinion on this, which is that the C# programmers of today are the C++ programmers of yesterday, okay, and maybe the Java programmers of yesterday.
Actually, Java is somewhere in between.
All right, I agree. I do agree with that. But they're definitely the C++ programmers of yesterday, right?
Right.
So C++ programmers, there's no doubt that they do not come from programming from a top-down approach. They come from a bottom-up approach. They come from understanding computer science, from typically more education in computer science, right?
Right.
They typically come out of colleges and they learn how to build up things from bits and bytes. Whereas a VB programmer comes from I have a business problem I want to solve. Here's a tool. Now I'm going to learn everything that I need to know about programming to get to my goal. And so it's a top-down approach to programming. It's a problem-solving as quickly as possible approach. And, that doesn't mean that they haven't met somewhere in the middle along the way. It's just that they've come to be programmers from different places. And the VB programmers that, are numerously out of work now, okay, the dot-com boom sort of put an end to big budgets and all that. The economy changed. Most of the programmers that were laid off were VB programmers because there was more of them. There was more people solving business problems than there were building, engineering,
Right.
system-level components, etc. Okay? So the VB programmers that are left are still paid their VB programmer salaries, and the C# programmers that were C++ programmers are still paid their C++ salaries.
Right.
So now we're not in a boom period of hiring. Therefore, there are more VB programmers out there looking for a job. Therefore,
supply and demand kicks
in. It's no wonder.
Right.
Okay.
And that actually raises a very interesting point that I've heard, and that is, if that is really the case, and you are a smart VB developer, from a purely mercenary standpoint, you might change your resume to say C#, because fundamentally, if you can do one, you can do the other, right?
But
yeah, absolutely. That's exactly the way I look at it.
Yeah.
If I were out of work as a VB programmer, I'd be learning C# if I thought that paid more money.
But here's the deal: if you were a manager who is hiring, you'd be hiring VB programmers because they're cheaper. This is not a boom time. This is not a period of supply and demand on the programmers to the programmers' benefit.
Right.
Well, yeah, it depends, though, Carl. If you're a company and you've set a standard that all of our development is going to be done in C#,
yeah, that's true.
A lot of companies are doing that.
That's true. A manager doesn't say, "I think I'll start a software company in this bad economy, and do I want C# or VB programmers?" That's not obviously happening.
Yeah, you'd have to be drinking to do that.
You'd have to be smoking crack. Yeah. So it's been at least several months since we had. Maybe even almost a year since we talked to you last.
Right.
What have you been doing in that period of time? I know you've been speaking a lot.
So I published a book. It's called Programming.NET Components. And in a shameless commercial plug, I invite the listeners to go and see what they say about it on Amazon.
Very good.
What publisher did you use?
It's O'Reilly again.
Okay.
And I basically wrote a book that I don't think anybody wrote about .NET before, because I wanted to put in writing my lessons and my perception on developing component technologies, based on years of doing it in COM and now in .NET, and distill what are the abstract principles of component programming, and then show how you implement those programming principles in .NET in concrete examples. And so in the first chapter, I define the 6 principles, and then basically I have 400 pages showing how to implement that in detail.
Wow, that's great.
And that's one thing I did. I do a lot of speaking and presentation, consulting, training.
Hey, if you send us a copy, we'll be sure to read it.
Well, not only that, I'll show it to classes and plug the book if I enjoy it.
Okay.
And I think
will.
I would.
Yeah.
I read your book on doing service components, also published by O'Reilly.
That's right.
Which was a very good book. You did a great job with that one.
Thank you. So once the book was off my shoulder, it feels like I've infinite amount of time, right? So now I'm doing more articles and speaking, consulting. I'm this week consulting in Atlanta. A little bit of training, and I'm gearing up for .NET 2.0.
Hey, I got a question. I heard from the .NET show that you were part of an architectural summit with guided design.
Right.
Tell me about that. What was that all about?
So last March, we did the first .NET Architecture Summit in Redmond, in Microsoft. And what we wanted to do a .NET Architecture Summit. Now, in many respects, a pure architecture Summit and such is not that much technology related, because the same design principles for Java would be applied to C++ and .NET. It's almost technology independent.
Sure.
But the moment you pick a technology, there's many architectural decisions that drive the technology. There's many technology decisions that actually affect the way you decide to actually do the layout and such, right? For example, we all know that we need to have a secure system, but what are the security options .NET provides? How do you manage identities? How do you manage transactions? And so on and so forth. And so we did the summit, and it was basically hosted by Guided Design and Microsoft. And
How, was it well attended?
Oh, it was very well attended. I think we had about 130 or so. And we're doing it again in October in Redmond. And we got guys from the .NET Pattern and Practices group at Microsoft to give presentations as well. And it's a very different crowd from what you see in normal conferences where it's just pure developers. This were, developer leads and architects and even some CTOs and technical management level people. And it was a very challenging audience, asked some very good questions. All in all, it was a blast. And that's coming again in October.
So is that open to just anyone that knows about the conference?
Yeah.
Or the summit?
That's right.
Hey, now we have something to crow about here at Franklin's Net. First of all, Mark Dunn is teaching the VBNet Masterclass in Atlanta. His very first appearance is going to be November 10th through the 14th. It's going to be at the AmeriSuites in Alpharetta, right near the mall in Atlanta. We're having an introductory 2-for-1 special. So buy one, get one free. Basically turns out to $1,000 a seat. And that's going to be November 10th through 14th. Okay, also get this. We finally finished the specs and all the content for our ASP.NET Masterclass, and Mark Dunn's going to teach this with Marcy Robillard, otherwise known as the Data Grid Girl. Hey, we've got a show coming up with Marcy next week, so you'll want to tune in for that. This is going to cover an incredible amount of ground in 5 days. Object-oriented features using inheritance with controls, server controls versus HTML controls, ADO.NET, SQL Server XML features, concurrency management, user controls, custom web controls, data binding, data grids, data lists, data repeater controls, editing, sorting, paging, custom paging, embedding controls, custom data grid columns, working with view state, dynamically creating columns, state management on the client and on the server, XML data islands, caching, reporting, using web services, stress testing, security, and more. This is an incredible class from two incredible teachers, Mark Dunn and Marcy Robillard. The first one is going to be next year, January 12th, at Franklin's Net, New London. The second class will be January 26th in Atlanta. Folks, it just keeps getting better. All right, let's get back to Juval Lowy right here on .NET Rocks. Isn't this great? This is one of my favorite shows. Hope you like it. Stick around.
You really haven't done any amount of generic stuff?
Well, as far as my exposure to generics, it's just been reading about Java in the past. I mean, I was familiar with the concept of generics. And I don't know that, I don't know that when I was reading about it that Java really, Sun's Java had implemented generics. They had a product that was codenamed Tiger a couple of years ago, or not even a couple of years ago. And generics was on the drawing board for Tiger. So I haven't really kept up with Java. I don't know if they implemented that yet or not.
So I'm not a Java expert by any stretch of the imagination. And what I want to tell you now was basically things I read on the C# website, where they have short documents comparing C# generics and Java generics. And according to that document, Sun doesn't want to make any changes to the Java virtual machine, changes to accommodate generics.
Ah, okay.
And as a result, they can only support generics in a limited fashion with reference types. So you can have a generic structure that hosts customer objects or other objects and such, but you can't use the same structures for integers or floats or booleans.
All right, so they're going to have a light version of generics compared to what we have in C# 2.0.
In my opinion, it's not even called generics, because the moment you put limitation on the actual types you're going to store, it's no longer generic. It's not that different from just using raw objects.
Right.
So, and again, it's a trade-off Sun had to make in order to not change its virtual machine, because Microsoft owns the CLR. It can make changes as much as it likes, right?
Yes, that's right.
Such as bringing generics to the IL level.
Right. And yeah, that's something I wanted to mention earlier, or actually ask you a question. So the implementation of generics in C# goes beyond just the C# compiler to MSIL compiler. It's got to be something supported at a lower level by the Common Language Runtime.
Yes. And that's Microsoft did a significant amount of work on the CLR to accommodate generics.
Right, and that also makes me think that would probably open the door for other languages to also support generics in the future.
As best as I can understand it, nothing prevents any language from consuming a C# generic data structure. Whether that language compiler is able to define generics is a different question altogether.
Right.
Yeah. I wonder how many. I wonder if that really is an issue for VB.NET programmers.
I don't think it is, and I don't think it is because Java doesn't have generics. Now you say, what's that got to do with anything? Under the assumption that we have this spectrum of skills and spectrum of developers' abilities and spectrum of experience and what you're going to use it for, which spans all the way from hardcore C++ through Java to .NET or C#, right?
Right.
If we have this spectrum, when Sun designed Java, it basically came up with a C++ derivative language. Yet they explicitly chose not to have some really powerful C++ features like operator overloading or templates. And I think the reason they chose not to do it was because they didn't want to, I won't say the word confuse, but they didn't want to burden developers who were not as savvy as C++ developers with language features that they're unlikely to take advantage of.
Okay, sure, yeah.
And so if we say that Java did pretty well without generics, right?
Right.
And assuming it targets a certain spectrum of audience, then I suspect that even if VB.NET is not going to have generics, it's going to do pretty well because its target audience never missed it.
Right.
So,
hey, I got a question for you. Totally shifting gears here for a minute. We now have two versions of the .NET framework, and I don't know about you, but having both versions on my machine as a developer is somewhat worrisome. And I'm wondering if you're experiencing, and if you're not currently experiencing, do you think you will be anytime soon experiencing framework hell?
I'm calling it .NET hell, yes.
Yeah.
And today I actually helped the customer with one of the biggest companies in the world to come up with a .NET coding standard. And one of the items I have over there is that you must specify explicitly, as part of your coding standard, I'm saying you must specify explicitly which version of the runtime you support. Having it resolved on the fly by some default policies is unacceptable for any serious application. And if you don't do that, then bad things might happen.
Right.
And the problem is especially severe for component vendors because application vendors, those who deploy the EXE, have kind of control about that because you can specify the support runtime in your configuration file. But if you're a class library and an EXE loads you use whatever CLR that EXE is using, period. You have no say on the matter. And that has potential for some serious trouble. This is why you have to certify your versions.
So do you fork the code and compile it twice or three times? Or how? I mean, we're supposedly having a new version every year. What's I mean?
Yeah. How do you solve that?
It's a tough cookie, and there's some solutions I can think of. I mean, one totally off-the-wall solution would be, how about a tool that you give customers that basically looks at all the class libraries they're using, sucks out all the hell out of them, create one big thing, and runs that.
I see what you mean.
So that would get just throw away all the class libraries.
But then you're not standard, and you have different.
Right. I'm not saying that this is actually a practical solution.
Yeah.
I'm saying it's off the wall.
I don't know as if you can have your cake and eat it too. I don't know as if you can have innovation in the framework without having to be backward compatible, without having to have.
That's right. And this is actually what is going on, because Microsoft, after about almost 20 years of living with DLL,
right,
realized that there's no such thing as full backward compatibility. It's a fiction. It doesn't exist. If you want to commit to that, you're either going to end up with DLL hell, or you're going to end up with a situation that totally stifles innovation. You can choose. That's your option. And
right.
So what Microsoft is saying is it's making something much more sophisticated. It's saying, because we can have side-by-side execution, we guarantee that at least we're not going to break your code if you have the older runtimes installed on the machine.
Right.
Things are going to work. Now, you want to take advantage of new features? Well, nobody's forcing you to do that, but then you have to certify that you do run with the correct version. And so that actually raises a different question, which is, should we treat .NET as an operating system? Because when we had operating systems, if your code ran on Windows on NT4, it doesn't mean it runs on Windows 2000 or on XP. Right? Nobody can make that assumption. You have to certify it, right?
That's right.
And so if you view .NET as basically something that is analogous to an operating system, then the fact that you run on .NET 1.1 doesn't mean you run on .NET 2.0.
Yeah.
Yeah, this makes me think of video games, of all things. If you look at video card support in various games, you run into kind of the same problem where, if you want to see all sorts of cool visual effects, well, you've got to have a certain version video card, or you don't get them.
Right.
So it could work the same way. If you want to get these features, then you've got to have the latest version of the framework installed.
And here's actually what I recommend my customers. I say to them that your deployment unit, what you put on your customer machine, is not just the 4K of your assembly, okay? You bundle all the runtimes you support, because there's no telling what you're going to end up on the customer machine. You can write a pretty smart installation that, looks up the customer GAC and see where it has a .NET installed in the correct version. If not, just install that. But you have to consider bundling the version you support with you, because otherwise you're playing Russian roulette with .NET.
Yeah, I agree. Well, Yuval, we're about out of time. Is there any other last-minute stuff you want to share with the audience?
No, guys. Thank you for having me. I can't wait for next year.
Yeah.
It's always a pleasure to talk to you, Juval.
Thank you. Absolutely.
And we'll see you in the fall in Palm Springs.
That's right. See you then, guys.
Okay. Take care.
Good night.
Life is hard.